I am Ramakrishna Reddy. Today we discuss about the orthogonality of two vectors, or three vectors, or a bunch of vectors. Right? If a bunch of vectors are all orthogonal, mean mutually orthogonal to each other, then we say that it's an orthogonal set. Further, if we can normalize those vectors, then the set is called orthonormal set. Basically, it depends upon the dot product between two vectors. Dot product in a higher dimension is called uh, inner product. Some they call it a scalar product. If you take two vectors in a two-dimensional space, say u equal to u1, u2, v equal to v1, v2, then the dot product or inner product, so we stick on to dot product. The dot product between two vectors u and v is denoted by u dot v, right? And is defined as u dot v is a component-wise multiplication. Similarly, if u and v are three-dimensional vectors, then u dot v is a component-wise multiplication. And in general, if it's n-dimensional vectors, in u and v, then u dot v is given by u1, v1, v2, v2, and un, vn. Basically, the dot product pops out a number, and that number will give you the degree of similarity. So, if you want to know the degree of similarity between two vectors, then we'll find the dot product, right? Dot product of a vector with itself will give you the magnitude of that vector. In a high dimensional space, we call it the norm of that vector. So norm u equal to root of u dot v. If norm equal to 0, then we'll say it's a zero vector. Further, if it's not a unit vector, we'll unitize it or we'll normalize it by dividing by its norm. So x is a vector, say x by divided by norm x will give you a unit vector, say u cap, right? If the dot product between the two vectors is 0, then we'll say that they are orthogonal vectors. So two vectors are said to be orthogonal if the dot product between them equal to 0 or u transpose v equal to 0. Here is an example. So here is a definition you can go through. Pairwise, mutually, that's what I say. If they are mutually orthogonal, then dot product between them is 0. Then all those bunch of vectors, the set of vectors which are mutually orthogonal to each other, that's pairwise, then the set itself is said to be an orthogonal set. Example, the three vectors in front of you, you find the dot product pairwise, mean x1, x2, x2, x3, x1, x3. And we'll see that the dot product between them pairwise is 0. So I say that these three vectors, they form a set which is an orthogonal set. Further, if we divide these three vectors by their norm or a magnitude, then we say that they are normalized. Then the set is called orthonormal set. Example, here is a v1, here is a v2, here is a v3. And first we'll ensure that they are mutually orthogonal. Here it is. Dot product between them pairwise is 0, so they are mutually orthogonal. Then I'll find the magnitude of each vector. For example, magnitude of v1 is, dot product with itself, root 2. The magnitude of v2 is a 2, and the magnitude of v3 is a 2. By dividing its form, by dividing each vector by its norm, that is u1 equal to v1 by norm v1, we get this vector, and u2 is this vector, and u3 is with these vectors. Meaning here v1, v2, v3 are normalized. And the set U1, U2, U3, it's called an orthonormal set. If a set of vectors are orthogonal, they are linearly independent, not vice versa. Here, it's made of complex numbers. Now, to bring in complex numbers also within its purview, then are they pairwise orthogonal? Yeah. Say V2, V3. So V2 transpose V3, rather V2 conjugate transpose V3 equal to 0. Similarly, V1 conjugate transpose V2, and so on and so forth. We see that all the three are mutually orthogonal and they form an orthonormal set. So, two vectors are said to be orthogonal if the dot product between them is 0 or if the inner product between them is 0. A bunch of vectors are said to be orthogonal if they are pairwise mutually orthogonal. And the set is said to be an orthogonal set. Further, if we divide each vector by its norm, then we get orthonormal set. Thank you.